Welcome to Study Loop.
We need to prove that this length s is equal to the length c times the tangent of theta, and we also need to prove that this length y is equal to the length c times the secant of theta. And I drew a free body diagram here with the angle theta about the horizontal. So we're going to start by first proving this equation right here. And to start, we can write that dy over dx is equal to the tangent of theta, which I'm going to rewrite as dy is equal to dx times the tangent of theta. And then I'm also going to write that the weight W divided by the tension T naught is equal to the tangent of theta. And we can see that this is true because if we look at the free body diagram, and if we look at the opposite of this angle, we can see that it's going to be this weight W, right? And then if we look at the adjacent of this angle, it's going to be this tension T naught. So now we can write that this dx times the tangent of theta is equal to the weight divided by the tension T naught times dx. And on the side here, I'm going to write that we know that T naught is equal to the weight per unit length times the length c, and this weight W is equal to the weight per unit length times the length s. So now we can write this now as ws divided by wc times dx, and these w's will cancel, and we can divide this dx on both sides. So we'll be left with the tangent of theta is equal to the length s divided by the length c, which we can then write as s is equal to c times the tangent of theta. Now we're now going to prove this second equation here. We're going to work with this one here. So by looking at the free body diagram, we can say that ds divided by dx is equal to the secant of theta. Since if we look at the free body diagram, the hypotenuse of this angle theta is going to be this ds, and the adjacent of this angle is going to be this dx here. And then we can write this as the tension T divided by the T naught. And we can do this for the same reason that we did ds divided by dx. And then on the side here, I'm gonna write that this tension T we can find as the weight per unit length times the length y, and this T naught we can find by taking the weight per unit length and multiplying it by the length c. So we can now write this as w times y divided by w times c And we can see now that these w's will cancel. And we can now write that the secant of theta is equal to y divided by c, which we can then write as y is equal to c times the secant of theta.